For this third video of homework 22, we are going to be taking two different functions and doing function composition again, just like we did before, except that these have a unique relationship. F of x and g of x in this problem, they are inverse functions of each other. And we are going to first verify that they are inverse functions by using function composition. And then this is, again, the same type of problem, except using different notation. So that here, 15 and 16 are the same type of problem, and they relate to example 10.7. So if you were to go over to 10.7 in the textbook, it's going to walk you through how do we do function composition when you have two different functions, and we use function composition, and they both come out with x, then you know you have inverse functions. For instance, if one function is putting the sock on, and the other function is taking the sock off, you should get your foot back. So what that looks like is we put a substitution of one function in for the other, and then it's going to simplify down to x. Let me show you here on my open math. Okay, f of g of x. G of x is going to be in pink. It's going to be this one. And then f of x is going to be in blue, this one. F of x is 5 times something minus 7. So here I have 5 times something minus 7. What am I plugging in as the something? I'm plugging in g of x. And what is g of x equal to? G of x is equal to x plus 7 divided by 5. Now if you distribute the 5 to the numerator, that's actually going to be inefficient. Instead, what you want to do is recognize that this is a 5 over 1, and then cancel this 5 here with this 5 here, and then that is going to leave you with x plus 7 minus 7. So here's the minus 7 that was at the end, and the resulting quotient, once you cancel here, is going to be x plus 7. And you can see then that x plus 7 minus 7 is going to equal x. So I just did this first one, part A. You repeat that again with part B, and you can see that it makes an x. Now this skill is a way to verify, it's a way to check your answers basically. When you are given an original function and you're given a supposed inverse function of the original function, how do you verify that they are in fact inverse functions of each other? You run function composition both ways, and if in both ways you run function composition, you end up with x as an output, then you know that you indeed have inverse functions. Okay, so that is going to cover 15 and 16, and now we're going to move down to 17 and 18. So in this particular case, let me hide these answers if I can. We're going to find the inverse function of two different functions. So here are the steps. When you want to find the steps, they are in the book in example 10.8. So the first thing you're going to do is you're going to replace f of x with y. So if your original function is f of x is equal to 4x plus 7, you replace f of x with y, and so now you have y is equal to 4x plus 7. And step 2 is to interchange the variables x and y. So switch x and y. You notice that y has now become x, and x has become y. Then, step 3 is to solve for y. So that means that you would subtract 7 from both sides and then divide both sides by 4. Step 4, substitute f inverse of x for y. So now we're rewriting y as f inverse of x. And then step 5, verify that the functions are inverses by showing the function composition and how you get x. Now we don't have to do step 5 here for my open math, but what we did in the previous two problems was to work on this skill. So step 5 is covered by the previous two problems. That's how we know we have inverses. Okay, so for my up in math, let's work through those steps. Step 1, take the original function and rewrite it so that f of x is replaced with y. Step 2, switch x and y. So now we are going to end up with x is equal to 5y minus 8. Just as an aside, from the previous video, I noticed that there's sometimes the case where writing is left on the screen here that I cannot see anymore, but that you can still see, which is how in the last video I ended up writing over my own writing. I couldn't see the other writing that was on the screen. So I had previously written right here, y is equal to 5x minus 8. If you can no longer see that, I've rewritten it here. So here's step 1. Rewriting f inverse as a y, and then step 2, I am now switching my x and my y variable, and then step 3, I have to get y all by itself. So that is going to give me x plus 8 is equal to 5y, and then I need to divide both sides by 5. And when I divide both sides by 5, I can then move on to step 4, which is to replace y, because this is just y, with f inverse of x. And so that is going to now give me f inverse of x is equal to x plus 8 over 5. Okay. And that's what you see right here in the answer key. So for question 18, you're going to do the same process again. This one's going to be a little trickier because you're going to have to square both sides, but the technique is going to be the same. So first, we're going to rewrite the original function as y equals square root of 5x plus 9. Then you need to switch x and y. And then after you switch x and y, you're going to square both sides. So my writing just got deleted again, so I'm hesitant to pause the video if it's going to keep deleting the writing that I have here. Anyway, what you should be seeing is x is equal to 5y plus 9, and we need to square both sides. So if you square both sides, you'll have an x squared here on the left. You end up squaring this right-hand side, and that square root and the square will cancel, because as it happens, they are inverse functions. And you end up with 5y plus 9, so then you need to subtract 9 from both sides and divide by 5, and if you subtract 9 from both sides and divide by 5, then you end up with the answer, and the answer then is x squared minus 9 divided by 5. Alright, so that's it for the lecture. Hopefully you were able to get through all 3 of those, and then I will be back in class, if everything goes to plan, on Wednesday, November 30th.